Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, co-founders, executives, entrepreneurs, thought leaders, you name it, all over the world of crypto and blockchain globally. And I have an amazing guest today for you, and I'm looking forward to this. I have the co-founder and the CEO of Archium, Yannik joining us. Yannik, welcome.
Hey, Jamir. Great pleasure to be here today. Very excited.
Awesome. So am I. Thank you for joining me. So let's kick things off. I ask everybody the same question. I get all kinds of great answers. And this, what is your background, and is it a logical background for what you're doing now?
Sure. So originally, I started, I think 12 years ago, so at the age of 12, to teach myself programming. So it has always been part of my childhood to program applications and just hack around with things. But then after high school, for some mysterious reason, I decided to go study law instead of pursuing mathematics, computer science, or physics. At the time I thought that it was the right decision. And even during studying law, I was very attracted to legal tech. So combining traditional law with automation, artificial intelligence, and just digital technology in order to make it more up to date, I guess. I noticed during COVID, when I had some spare lecture free time, that I was drawn back more heavily into this computer science realm. And at that point, I was just programming a quite simple application that helped me at that time to use my iPad Pro as a full desktop computer, because they were in the trend during COVID. Everyone was working from home. So I was programming an application that allowed a secondary monitor to be connected to your iPad and then have the full desktop work experience. And overnight, that turned into a big success. And so at that point, during my last civil law course, I then decided, okay, let's switch things up. Let's instead go back to mathematics and computer science. And so that's how I came back to my original passion. And then I met my co-founders studying at university, and all of us were doing computer science and math, and we were just intrigued by blockchain systems and privacy technology, essentially. And so that's how we ended up teaming up to build now Confidential Compute, and originally when we started off, just general on-chain privacy. And I've always been a sort of privacy fanatic, I would say. So I think one of the biggest achievements in my life so far has been onboarding my entire family into using Signal as primary messenger, and family communications now running over Signal instead of Zuckerberg's WhatsApp. Yeah.
We got some things to talk about. We got things in common. Very cool. Yeah, who introduced me to Signal was John Draper, the Crunch Man, back in 2017. And he told me all about that. And I haven't followed up with him in years, but I don't know. But yeah, Signal's a great platform, and confidential computing, and I'm going to get into that too. First of all, I want to find out though, what is Archium all about, and how do you redefine trust in this digital age?
Yeah, sure. So what we are essentially trying to tackle is we want to remove trust from computing, because in the centralized computing world, there's many actors involved that one has to trust, their data and the processing over the data with, right? And so we, on a day-to-day basis, see data exploits. the attacks on individuals, on corporations, and most of those exploits are due to the infrastructure that is being used, and that infrastructure, as this centralized infrastructure, being very prone to attacks. And so for us, it's this introduction of confidential computing and decentralized confidential compute. And what's this amazing concept about confidential computing is that operations can be performed over encrypted data without having to decrypt the data first, right? So you can encrypt data, make it secure, make it inaccessible to anyone, while still be able to process that data. And this is a concept that has been pursued in the traditional computing space as well for quite some time. So the go-to technology in general has been so-called trusted execution environments, which are dedicated chips provided by hardware manufacturers, together with some security and data privacy promises associated with them. But yeah, similar to just generalized server infrastructure, what we've seen with these kinds of systems is that they inherently require trust by whoever's using them. And so for us, it has always been the struggle to remove trust and replace those trusted systems with cryptography-based systems, so that the only trust assumption, I guess, you require is that some mathematical proof is valid. And so, yeah, I think that's where we're standing in order to redefine trust. We can get into the more detailed technical ways we're facilitating that, I guess. But in general, our approach is decentralize things and introduce cryptographic protocols that protect data and allow arbitrary computations to be executed over that data. So what we are trying to achieve is everything to become encrypted and anything to be possible to be computed over that encrypted data. Yeah.
Very cool. I do want to get into technicals. We'll do that after this question. I want to find out, I saw an announcement that you are now part of the new DECC. What is that all about, and what is your role and your vision for your role in it?
Yeah, sure. So essentially the idea was to give this kind of vision and mission that Archium, but also other protocols from the blockchain ecosystem are pursuing its own term, a catchy term, and a term that actually reflects what we're trying to achieve. And so we call it DCC, decentralized confidential computing. And essentially what we are doing is establishing a coalition for data protection. And I think the main reasoning is that we require more education about what we're trying to do here. We require more education about the importance of data security and also the kind of solutions that exist out there. So there needs to be more education, and if we unite as startups in this space, we are able to facilitate this education in the ecosystem. And then, we want to clearly have this sort of separated new category for Web3 technology with decentralized confidential computing. And for us, it's important to ensure that those use cases that DCC offers expand upon financial use cases. So it's not just about financial privacy. Decentralized confidential compute is generalized confidential compute. So the ability to create encrypted fully confidential smart contracts that can perform any action and perform arbitrary on-chain actions, but at the same time use this technology to also facilitate confidential off-chain operations. So in general, what with decentralized confidential compute we are trying to achieve is to offer a sort of new cloud, if you will. So really a computation execution environment that can be used both by enterprises, but can also be used for confidential smart contract applications. And so there was just this need in the entire blockchain ecosystem to introduce a new term that really, values the uniqueness of what we are trying to achieve.
I looked at some of the companies and projects in that coalition, they're pretty strong. So you're in good hands and you're a good company, I think. I do want to find out then now how Archium can help enhance data security, and the technical side, right, for large healthcare providers.
Yeah, sure. All right. So let's get into it. So first things first, I think what's important about our approach and might even be unique in the DCZ or just blockchain space in general, I think, is that for us, we don't just we didn't came about using blockchains or decentralization for blockchains or decentralization's sake, but instead because using decentralization and blockchain together with the cryptography that we're using is just this natural fit that allows for new properties to emerge. And so the core technology that we're using is so-called secure multi-party computations. And they are a cryptographic primitive that allows a set of parties to collaboratively run a computation over distributed data, so data that every one of those parties holds, without having to share that data. So the two of us could be able, using a multi-party computation protocol, to compute the average of our salaries or our income, our net worth, whatever, without having to disclose any direct information. We are able to compute anything in a distributed way and can receive the output, but there's no risk of the data, the input data, or the intermediary results to be leaked. So that's a very powerful cryptographic primitive. And at the core of how multi-party computations work is this concept of secret sharing. So if there's multiple parties that run a computation and they have private input data, they're secrets, they take those secrets, split them into shares, essentially blinded, randomized data at that point, and distribute that data to the other participants. And they can't gain any knowledge about the original secret just from those shares. Only all shares combined back together can form the secret. And so multi-party computation essentially means multiple parties taking their secrets, creating randomized blinded shares, sending them to the other parties. So everyone has this heap of shares and then running a computation over those shares. And what we're using for that is so-called somewhat homomorphic encryption, which essentially means that one operation is very easy and efficient to be executed over this data. So how you can imagine it really is each player having their data and then just running a local computation over that data. And they can't learn anything from running this computation because it's just this random data that they are operating over. And then some communication is involved between the participants, exchanging some intermediary results, running more computations, and then at the end, they reconstruct the output. And that's this core principle of multi-party computation that we're utilizing. And what's so beautiful about this technology compared to others is that there's two properties that we care about: trustlessness, but also performance, because there are very trustless technology. So for example, fully homomorphic encryption, which on its own could be more trustless even than the technology that we are using. But at the same time, having to force, in this example, healthcare providers to run computations at a 10,000 to 100,000 times slowdown performance latency is so unreasonable that no one will opt to use privacy enhancing technology, right? So it always matters that we're able to actually supply a practical solution. And what we found in practice is that even those fully homomorphic encryption-based systems have trust assumptions involved that are the same than the trust assumptions that we use with multi-party computation. So what are those trust assumptions? Those trust assumptions basically can be boiled down to two cases, honest majority and dishonest majority. So honest majority protocols, like with practical Byzantine fault tolerance, would imply that in a computation, more than half of participants would have to behave honest in order for the computation to hold confidentiality. For us, that's not really a reasonable enough trust assumption, because having to trust that more than half of players in such a computation are honest seems risky. And so the trust assumption that we prefer and that we are using is the dishonest majority trust assumption. So, which means in a set of participants, there only has to be one honest participant. So one honest participant is the requirement, which means if you have a set of 2 players, you would just have this chance of one of them being honest. But if you have a set of 10, 100 or more players, it becomes a really reasonable trust assumption, especially if for those computations, they are sort of permissionless and you having the ability to become an honest player, right? So if you can also be part of the computation with the others and you being honest, which should be the trust assumption against yourself if you care about the confidentiality of your data in general, then this becomes a zero trust game, essentially. And so that's what we are able to facilitate trust-wise. And performance-wise, what we're utilizing are essentially breakthroughs in multi-party computation, protocol breakthroughs over the last years in the so-called pre-processing model. So splitting the computation into 2 phases, a pre-processing phase and an online phase. And the pre-processing phase just generating so-called correlated randomness that can be consumed in the online phase, but this pre-processing phase being completely independent of whatever is being executed in this online phase. So by splitting those computations, it's possible to have execution in this online phase where the actual inputs and the algorithm, the function of the computation is being used, allows this phase to come to very close to plain text execution speed, which is, again, super important because every time you want to have an enterprise or a blockchain protocol or anyone utilize privacy enhancing technology, it can't, and that's what has been shown in practice, it can't really enforce the sort of high performance or cost penalty upon the company using it or the end user, right? You should not have to go out of your way to have privacy. And that's really what we're trying to achieve. And so what we're building out with Arcium, using this technology at our core, is a parallelized confidential computing network. So a purely computational network that is sort of chain agnostic, that is able to run those computations. And what that means is that as a healthcare provider, what you can do with Arcium is you can create a so-called MXE, MPC execution environment, which is a virtual encrypted environment you can open such an environment and you can define encrypted state and you can define functions and then just let the network run confidential operations over that state without you trusting some singular server that could be hacked. So it's this secure execution environment, which can be provided as a replacement to those traditional centralized server applications. But more importantly, I think that's only one of the use cases, this autonomous execution environment, if you will. What's so fascinating about the technology we have and this core primitive of multi-party computations is that we can directly facilitate things like federated learning with them, right? So if we have 10 hospitals that have access to super sensitive patient data, I, as an individual, don't want those hospitals to share my data. And from a regulatory standpoint, I also have the right to expect that they will not share my data. At the same time, as a patient, I would love if in general we had a healthcare system where it's possible to predict using machine learning, for example, diseases as early as possible, right? But I don't want my data to be shared or exploited. So with the technology we're building, it becomes possible to use this data to gain insights without ever having to risk that data. So what's possible is to use Arcium as 10 hospitals, and every hospital remains the owner of their sensitive data, while at the same time, they're able to train a machine learning algorithm over that sensitive data that can predict different kinds of diseases without ever exposing any of the patient data. And with this system, we can even go full circle. So it doesn't even have to be those parties just training together and receiving some plain text machine learning model. It can even be this machine learning model remaining encrypted forever. So they just provide original data, train with Arcium, with an MXE, which creates an encrypted machine learning model. And then a doctor wants to predict the likelihood of someone having this disease that has been trained on those features. And they confidentially provide their data. So the data that they use as inputs for the prediction is also not being exposed on this encrypted model. They get their prediction back and no data ever is being leaked. So it's really end-to-end encrypted AI, if you will, at that point. And so I think that would be a very straightforward use case that we are able to facilitate with Arcium for large healthcare providers, I think.
I love it. I'm speaking, I was silently clapping. So there's a few things. So number one, I want to make sure I understand this right, first of all, from the technical perspective, because I've talked to people about multi-party computing, and you're the only one using it in this manner. You assume because you're working with randomness, you assume everybody's dishonest, but one person is honest, which gives you your control factor, and then everybody else can be random and dishonest because you have that one base, right?
Yeah, and it can be anyone, right? If we have a set of 100 computers, you're one computer, I'm one computer. You could be honest, I could be honest, the both of us could be honest. Doesn't matter as long as there's one person that it's not part of this malicious group trying to control everything. Yeah.
Okay, I understand. That's brilliant, and that's why it works. Number two, I got to say I'm part of I've been part of a few studies. Health-wise, I got this rare thing that 1 in 2 million.
Oh shit.
And I've had it for the whole entire time I've been podcasting, 3.5 years. It's not doesn't metastasize. The tumor does not metastasize, but there's a new drug that came out in December, and there's been studies since. I'm part of that. I'm not. I answer everything honestly. But you're saying that like these medical companies, these pharma companies that are conducting research with people like me in there, if they use your platform, what will be the benefits to them to be, as part of this clinical research, as part of these trials? What insights could they be able to gain to use, and why should they use you?
Yeah. So I think there's multiple aspects to that. One is that it's impossible without this kind of cryptography-based security to have this cross-entity collaboration, because the data just under data protection laws cannot be shared and processed in such a way. So there we have this regulatory limit potentially. Now, what I think is more interesting is that we can have new forms of collaboration, even between competitors, arise. Because if you that doesn't have to be in the healthcare sector, right? If we think about supply chain, for example, right? We have different logistics players that have data, and all competitors would benefit from shared insights or from some shared models. But they can't or are not willing to share any of their sensitive customer, company, whatever data. With this kind of system, they're able to do so. So completely new intelligence and insights can arise from this kind of collaborative approach. So I think it's just this win-win situation where you don't have to give up any of your data.
Got it. So I want to investigate this because you probably have a good answer. I interviewed a federated learning company a couple weeks ago, and a lot of people use ChatGPT. Federated learning provides a better data set for AI for companies doing your kind of research than just the regular ChatGPT social grab. What are your thoughts on why federated?
What was the why that's the case? So I think it boils down to sensitive data that can be used. I think the patient example really highlights that. It's really this tension if we think about it on an individual level, because that's, I think, what we need to think about for this healthcare case. It's really on an individual level, having sensitive data that has to be protected, right? Again, I'm the biggest privacy advocate, and what I found is just that with this kind of technology, I can have both privacy and at the same time get the benefits of confidentially operating over my encrypted data. So I think it's completely new types of data that haven't been used before, cannot be used, and also where I think in this kind of example with federated learning and blockchain come into play is the ability to have better data, because there can be a real incentive structure behind the data. So it can be you provide a good encrypted data set, and you can even generate a zero knowledge proof about the quality of your data set, for example, right? And then this training process can happen in a verifiable way. So everyone can be convinced, okay, this model has been trained on good data, and whoever provided the data is rewarded correspondingly. So I think that just really, there's more potential. I wouldn't say that in any case the models would be better, but I think there's just more potential that better data and more sensitive data can be used. Yeah. And I think it's really about also cross-referencing data, right? So a good example could be just the government in general. If you were to use tax data, social security data, all of that, cross-reference it, train models on that, you potentially would be able to use policies you want to create and predict the outcome of those policies on different different parts of the country, I guess, right? So but things like that are not possible because this data can't be shared. But it could be utilized if done securely, cryptographically with what you're building, for example. So it's just completely new kinds of cross-referencing and data connections being able. Yeah.
I like it. I like the idea. I like the concept of that, of thinking about what to implement and then using, DPP, using the multi-chain, multi-party computing, using federated, using your platform really to predict what the outcome will be. I mean, I think that's very fascinating, and I wonder, if we can do that, then what's possible.
Exactly right, and the beautiful thing is that it, and that's really what's driving the team, and that's again, blockchain comes into play here mainly because for MPC it allows us to have that's something that I wasn't even able to talk about, but implementing a new kind of cryptographic protocol combined with MPC that allows us to enforce execution, to have censorship resistance for especially those autonomous execution use cases, right, where this confidential computing environment replaces sort of your centralized server. So we are able to do that and cryptographically identify a party that is misbehaving, right? So in this multi-party computation, we have this perfect trust assumption, but at the same time, those MPC scientific papers in this dishonest majority trust model have this practical limitation that one dishonest player can DDoS the computation. So they can just force the computation to abort by sharing wrong data. And then the computation doesn't produce output, which in this decentralized setting is not ideal if you want guaranteed operation over your encrypted state. So we were able to implement a protocol that allows the participants not only to identify that something wrong has happened, because that's being identified always, but to pinpoint the player who misbehaved, so-called cheater identification. And with this protocol, combined with a collateral staking and slashing mechanism, we can enforce guaranteed correct execution in this network. So that for one is where blockchain comes into play for us, and also using decentralization techniques and transparency techniques. So you can have this this public ledger of the history of those computation nodes, how they operated, with what other nodes they run operations, their uptime, if they ever cheated, if they ever misbehaved. So things like that just add this trustlessness that further reduce this trust assumption. So we can, have the trust assumption go down even further, right? So that's where blockchain really comes into play for us. It's just this logical fit of those two kinds of technologies. And for us, really the driving force, to get back to our previous point, is that we realized just when playing around with the technology and reading the papers, what's possible to be done with this decentralized confidential compute, because it allows us to have these kinds of insights that that benefit our societies and humanity in general, without having to risk the individual's freedom and privacy. And I think that's so powerful. And that's what we're trying to achieve.
I hope you achieve it. It sounds wonderful. Wow. Great. This place, this industry keeps evolving every day. I'm happy to be here to see it. So I want to thank you very much for speaking with me today. I really enjoyed speaking with you. And I have one last question. It's really simple. So how can people find out more information about Archium and about you? How can they start to use your platform?
Yeah, first of all, it was a pleasure talking to you as well. And so you can go to archium.com. So importantly, Archium spelled with a C, not with a K, archium.com. The name actually comes from the Latin plural form of arcs. So Archium network, if translated from Latin, would mean the network of fortresses. And so you can learn more about our network at our website or on our Twitter at ArchiumHQ. And right now, we're in the phase of rolling out the private testnet. So we're testing the infrastructure, we're onboarding node operators and developers to test out the network. And then step by step, we want to go through multiple iterations of the private testnet, move to public testnet, and then eventually to mainnet. So that's the stage we're currently at. So you can learn more about Archium by just joining our community. We've seen incredible growth of our Discord server, for example, and I'm doing every 2 weeks a session of Archium Declassified, is how we call the series there, where I talk about the technology, use cases, updates, what we're doing. So that's a great place to learn more.
Excellent. Thank you very much for your time today.
All right. Thank you so much, Shamir. It was a pleasure.